Comet, asteroid, or something else? A Harvard astrophysicist believes there's a strong likelihood this is a craft of alien origin.
It accelerated. As 3I Atlas, our first visitor from interstellar space, swung around the sun, it pushed on the gas.
It's moving at a velocity of about 135,000 miles per hour, so it's going really fast.
This object, traveling faster than any comet or asteroid from our own neighborhood, suddenly gained speed for no reason at all. There was no gas, no tail, no engine, just a silent, inexplicable push that altered its path out of our solar system forever. This single event, this impossible trajectory shift, has been called the most significant discovery in decades. Many people are crazy about the idea that it was just an odd comet, but the data suggests something far more profound and unsettling. A guest from the void. On the 19th of October 2017, humanity's view of the cosmos changed forever. From a mountaintop in Hawaii, the Pan-STARRS 1 telescope, a sentinel scanning the heavens for potential threats, flagged something bizarre. It was a faint pinprick of light moving at a speed that made no sense. You see, everything in our solar system is tethered by the sun's gravity, moving in predictable, looping orbits. But not this. This object was on a one-way trip, an open-ended arc that meant it came from the vast, dark expanse between the stars. It was moving at an eye-watering 160,000 miles per hour relative to the sun. To put it mildly, it was an interstellar interloper. Scientists scrambled, pointing every telescope they could at the fleeting visitor. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first, though it would later be cataloged officially, fitting the mystery as 3I Atlas. What many overlooked in the initial excitement was just how weird this thing was. As they measured the light reflecting off its surface, they found it was unlike anything in our solar system. The data suggested an object that was exceptionally elongated, perhaps 10 times longer than it was wide, like a cosmic cigar, or, as later analysis suggested, a flat pancake no thicker than a few feet. It was dark red, the color of rock baked by cosmic rays for millions, maybe billions, of years. The most shocking fact is it was completely inert. Comets, when they get close to the sun, warm up and spew gas and dust, creating a glowing halo called a coma, and often a spectacular tail. This process, known as outgassing, acts like a tiny rocket engine, giving the comet a gentle push that can alter its trajectory. But Atlas had no coma. None. The Spitzer Space Telescope, one of our most powerful instruments, stared at it, looking for any hint of carbon gas, the main component of cometary tails. It found nothing. This wasn't a comet, but it also wasn't just an asteroid. Asteroids don't change course on their own, and you can see this everywhere in our own asteroid belt. They are slaves to gravity. This thing, however, was about to break the rules. It was already racing away, having made its closest pass to the sun nearly a month before it was even discovered. It was a cosmic coincidence of the highest order that we even saw it at all. It zipped inside the orbit of Mercury, swung around the sun, and then crossed Earth's orbit on its way back out into the void. Each day it traveled another 1.5 million miles further away. Our window to observe it was terrifyingly brief, but in that short time, astronomers collected enough data to uncover an anomaly so profound it would divide the scientific community and ignite a firestorm of controversy. The object was quiet, dark, and tumbling strangely through space, but it was hiding a secret that would only be revealed when scientists plotted its escape. The data didn't lie. After it passed the sun, Atlas started to speed up. Not driven by gravity. Gravity is the ultimate rule keeper of the cosmos. It dictates how planets orbit, how stars form, and how galaxies hold together. For any object passing through our solar system, its path should be perfectly predictable, governed only by the immense gravitational pull of the sun. But as astronomers at NASA's Jet Propulsion Laboratory meticulously tracked 3I Atlas's exit, they saw something that couldn't be real. The object was deviating from its calculated path. It wasn't by much, a tiny fractional percentage, but in the precision of celestial mechanics, it was a colossal error. The thing nobody tells you is that it wasn't slowing down as expected. It was hitting the accelerator. This phenomenon was labeled non-gravitational acceleration. It was a push coming from somewhere other than the pull of the sun. The team checked and rechecked their math. Could it be a mistake? An error in the measurements? Number. Data from the Hubble Space Telescope confirmed it. Atlas was being pushed away from the sun with a gentle but persistent force. The explanation for this is usually simple: outgassing. As a comet heats up, jets of gas act like thrusters. But this explanation had a fatal flaw. Atlas had no visible gas, no dust, no coma whatsoever. The Spitzer Space Telescope's observations had already proven that. For Atlas to be pushed by outgassing, it would need to be expelling a significant amount of material, which would have been easily seen. Many people are crazy about finding a natural explanation, so scientists proposed wild new theories. Could it be a new kind of comet, one that spewed invisible gases like pure hydrogen? The problem is, hydrogen icebergs shouldn't exist in nature. They'd evaporate in deep space long before reaching us. Another idea was that Atlas was a nitrogen iceberg, a chip off a Pluto-like planet from another solar system. This was a more plausible theory, as nitrogen gas could be harder to detect. But to produce the observed push, the outgassing would have had to be perfectly uniform, coming from one side of the object, which seemed incredibly unlikely for a tumbling, oddly shaped rock. The most shocking fact is how perfectly the push matched the sun's influence. The force acting on Atlas was inversely proportional to the square of its distance from the sun. In simpler terms, the closer it was to the sun, the stronger the push. As it moved away, the push got weaker, in a smooth, predictable way. This wasn't some random sputtering jet. It was a constant, steady pressure. To put it mildly, it looked exactly like the object was using the sun's own energy to propel itself. It behaved precisely how a solar sail would, a piece of technology designed to ride on the pressure of sunlight itself. And that's when the conversation shifted from geology to engineering. The world's top astronomer at Harvard finally said what others were only thinking: not made by nature. What many overlooked was that science fiction had predicted 3I Atlas decades ago. The idea of a solar sail, a vast, thin sheet that catches photons from a star the way a ship's sail catches the wind, has been a staple of theoretical space travel. Sunlight itself exerts a tiny amount of pressure. For a very large, very lightweight object, this pressure is enough to generate thrust, and the acceleration produced by a solar sail would match Atlas's mysterious push perfectly. It would be strongest near the sun and weaken as it moved away. The thing nobody tells you is that this wasn't just a wild theory. It was the explanation that best fit all the available data. And the person who championed it was no fringe theorist, but the former chair of Harvard's astronomy department, Avi Loeb. Loeb and his colleague Shmuel Bialy published a paper that sent shockwaves through the scientific world. They proposed that Atlas was not a natural object at all, but an artifact of an extraterrestrial civilization. They argued that its strange, elongated shape, its lack of outgassing, and its precise solar pressure-like acceleration all pointed to one conclusion. It was a probe, a piece of alien equipment. Perhaps it was a defunct piece of technology drifting through the cosmos for eons. Or, more tantalizingly, maybe it was an active reconnaissance probe sent to get a close look at our solar system. The pancake shape, they noted, was the most effective design for a solar sail. Many people are crazy about dismissing this idea immediately, but the evidence was compelling. Consider the numbers. The object was estimated to be somewhere between 300 and 3,000 feet long, but potentially only a few feet thick. This extreme aspect ratio is not found in nature. We've never seen an asteroid or comet shaped like that. Furthermore, its trajectory was peculiar. It wasn't aligned with the plane of our solar system where most objects orbit. It came in at a steep angle, used the sun for a gravity assist maneuver, and then got an extra boost on its way out. You see, this is exactly the kind of path you might plot if you were sending a probe on a flyby mission. The most shocking fact is that Atlas was unusually bright for its size. It was about 10 times more reflective than a typical solar system comet or asteroid. This high reflectivity is another characteristic you'd expect from a manufactured object, perhaps one with a metallic surface, like a solar sail. Could Atlas be a piece of a larger ship, a buoy from an interstellar shipping lane, or a discarded piece of alien trash? Loeb argued that statistically, based on the number of stars in our galaxy, it's more likely we'd see alien debris before we'd get a radio signal. In his view, Atlas was the first piece of that debris. The scientific community was now forced to consider a possibility once relegated to movies. But as the alien theory gained traction, other scientists scrambled to find a natural explanation, no matter how exotic. Natural or artificial? The idea of an alien probe is thrilling, a concept that leaps directly from the pages of science fiction into the sterile halls of astronomy. But science demands a cold, hard skepticism. The theory of 3I/Atlas as a solar sail, famously proposed by Harvard astrophysicist Avi Loeb, was met with fierce, almost immediate resistance from the wider scientific community. You see, the thing nobody tells you is that in science, extraordinary claims require truly extraordinary evidence, and for many astronomers, the data on Atlas was just too sparse, too fleeting, to make such a monumental leap. The object was observed for only 11 frantic days before it became too faint to see, a cosmic ghost disappearing back into the infinite darkness from which it came. There was no time to launch a mission, no chance to get a second look. So scientists got to work, scrambling to find a plausible natural explanation that could fit the bizarre facts, even if it meant inventing entirely new types of cosmic objects to do so. The nitrogen iceberg theory quickly became the frontrunner. Proposed by astrophysicists Alan Jackson and Steve Desch, this elegant idea suggests Atlas was not technology, but a pristine chunk of frozen nitrogen knocked off the surface of an exo-Pluto, a cold, distant dwarf planet in another solar system. As this cosmic shard neared our sun, the solid nitrogen would sublimate, turning directly into invisible gas. This outgassing would act like a gentle, unseen rocket engine, creating the mysterious push that caused its acceleration without producing a visible cometary tail or coma. This clever theory seemed to solve everything. It explained the acceleration, the lack of a tail, and even its strange flattened shape. As the iceberg evaporated under the sun's heat, it would naturally erode into a flat, pancake-like sliver. To put it mildly, it was a brilliant and elegant solution that didn't require invoking aliens. However, this theory has its own glaring problems. For it to be true, there would have to be an incredible number of these exo-Plutos in the galaxy, far more than our models predict, all conveniently shedding nitrogen fragments for one to randomly fly through our solar system. Furthermore, many question if a brittle nitrogen iceberg could even survive the millions of years of travel through the harsh radiation of interstellar space without being eroded into nothing. It requires us to believe in an object whose origin is, as of now, completely hypothetical. So where does that leave us? We are standing at a profound fork in the road of understanding our universe. On one side, we have the alien probe theory, a single, straightforward explanation that fits all the observations, from the unusual shape and high reflectivity to the precise nature of its non-gravitational acceleration. It answers every question, but asks us to make the biggest leap of faith in human history. On the other, we have the nitrogen iceberg theory, a purely natural explanation that requires us to believe in a new, unobserved type of celestial body, created by a hypothetical class of planets that just happened to be the very first interstellar visitor we ever saw up close. Many people are crazy about finding that one piece of data that solves it all, but the truth is, Atlas is gone forever. We will never get a closer look. We are left with only its ghost in the data, a faint trail of breadcrumbs leading to an answer we can never confirm, and maybe that's the entire point. People watching this are looking for that mystery, that sense of wonder. We ask ourselves, if this really happens, are we missing the key details? The thing is, Atlas forced us to confront the absolute limits of our knowledge and the boundaries of our imagination. The story of 3I Atlas is a reminder that we are just beginning to explore the cosmic ocean. What other messengers are on their way? And will the next one stop to say hello? Let us know what you think in the comments, and don't forget to like and subscribe for more dives into the universe's greatest mysteries.